Am I? Yes. I think I can start. Yesterday, I did cover a few of these topics. So not a few of these. I actually only covered the memory portion and a little bit about this, the cache thing. Like I covered all this from memory hierarchy part, and I did start learning this cache mapping techniques, and I'm done with this part for now. So I think so what I am thinking of is that doing this portion, I will just do these portions on my own. So it is not something which I will be covering today. So this was for something from yesterday. So what I have decided to do today is go for some OT questions for C programming, because I think I need to be preparing for it, and I know C programming enough to program something in it. Even if it is complex, I can at least learn what it is saying without losing that much sweat. So it is not like I am learning everything, exactly everything from scratch, right, when I program in C. So I'm fairly comfortable in it. So I think it is a nice time to just revise everything and just go for it. Let's look into what is something which I have not studied properly yet. So yeah, I think I can get started. um, I asked AI to produce 30 questions for C programming OT question, which are regarding struct padding, syntax questions, other things which comes under embedded systems, and let's see what these talk about. And if I don't know something, I will be going up and looking for it on the internet. So let's see. So first thing is, what is struct padding in C and why does it again? This might contain some simple questions as well, but like the thing is that it's not about the question and all. All it is about is whether I'm able to explain it properly or not, right? So that is the main focus for me as of right now. So I think I can get started with it. So the first question being, what is struct padding in C and why does it occur? See, the thing with struct padding is that you basically, when you are having something like a struct, you want to access it at some point, and it is not just a simple thing which just is like a byte or a, it is not something like it is just a single byte or like a bit or like 4 bytes, something like that. It can be a long thing as well. Um, it can be a big data structure as well. So when you're trying to access values from these structs, what you want to is access a full value all at once. Like let's say I want to value something inside a struct, like let there be 3 values A, B, C, D. So the way CPU works, it has something to do with CPU. The way CPU works is that the what you want to is access the values from this struct in the least amount of time and with least amount of operations as possible. And what struct padding does is that it allows you to access variables inside a struct in least amount of time, like it is the most optimized way to do this. And again this is because it is an optimization as well, and like there is literally no magic going on. Like it works on same computer as that as you are having. So what the issue here becomes is that you are making a trade-off for something, and that trade-off is space. So what happens over here is that let's say you are trying to access some values from it, and if you just pack every values on struct just bit by bit, if you do so, then you will face an issue, because let's say you are having a computer with a specific number of bits which can be input and output, like it can be read, right? You cannot do IO with literally like 40 bytes, something like that, all at once, right? You can only do a certain amount, like for 32 bits computer, 32 bits or like 4 bytes at once. This is all you can do, right? So what you want to do is, when you are doing that 4 bytes of data, when you are taking 4 bytes of data, what you want to make sure is that when you take data from it, it is not like I have taken some data from this specific memory location right now, but I think some of the data is here, some bits which I needed are here, but some bits are stored somewhere else, right? For just a simple thing which could be accessed in, let's say, just one cycle, like just one input output, one read or write. So that is not something what you want. So to face that, to enhance that, the way struct padding works is that it lays out every each and every variables which are there in the structs, each and every elements which are there in the struct, in such a way inside memory that it becomes it makes it such that it is the best way to access it, the fastest way to access it, the best way to access it, such that you don't have to do some extra work when it could be avoided, right? So that is how it works. And again, it utilizes some memory. So what it does is take extra memory and create some padding inside it, so that the memory is laid out such that there is not like some bits are there in one memory segment and other is in other memory segment, and you have to join both of these together, when it could be avoided. Not like it is avoided each and every time, it cannot happen like that, but when it can be avoided, it has to be avoided. That's the thing. So that's how struct padding works. That's why it occurs. It is a design choice. It is basically there to minimize number of instructions, number of input output you need to do to alter some data in memory, right? And that is what struct padding is. How can you minimize padding in a struct? Give an example. How to minimize padding in a struct? Give an example. So to minimize padding in a struct, of course, the one way is to, like, of course, the simpler method is to um, again, I think there are two ways of doing it, and one is kind of not so rigid of a method, like it's not like you can just each and every time go for that method. But there is one method. That method is that whenever you are including variables inside a struct, like say there could be like characters, integers, and all those stuff, right? So what you would want to do is that if let's say something takes, let's say you have something, a character which takes just 1 byte, right? And if you have something like an integer or long, right, it takes 4 to 8 bytes, right? So if you are declaring it such a way that you have character first, then integer first, and character first, the way it will work is that you will have character laid out in the memory first. And if let's say, let's not take integer, let's take a long, for example. So the way a computer would work is that it can only take a single long all at once, right? So whenever you are trying to access this long from the struct, there is already an a present, and if you want to access the whole long, it's not like you can just skip it's not like you can just take long from certain bits and then go in for legs. That's how pairing works, right? So there will be a gap between character which you are having and then the long which you are having. So this will make it like this will make the struct take two sizes of whatever the size long is, which I think is 64 bits, I think. 8 bytes, I think, along. So for you are having 8 bytes at once, right? You are taking 8 byte at once for long. So the padding will be such a way that you are taking 8 bytes for a character as well. So if you add something not let's not go there, because between this character and before the long comes, there is 8 bits, 8 bits of space. In that 8 bits there is one byte, not 8 bits, 8 bytes of space, and that one byte is taken by the character, right? So all those 7 bytes are just wasted. And if you, even if you are now adding any other variable, any new variable, it will be added in the memory after the long, so it will also take struct padding. So if you add one more variable, let's say another character, it will go after the long and it will take another 8 bits, right? So you are technically taking 8 24 bytes. I'm saying bits for again and again, I apologize for that, but you are having 3 into 8 bytes, which will be 24 bytes for no reason. When what you could do is take two characters all at once, first of all, the at initially, so that you have a character, you have another character, and both of these can be accessed at the same time, right? You don't need to what was I saying? Yeah, you can access both of these characters all at the same time, and then you can have that long. So that 7 bytes which were being wasted, now there will be only 6 bytes wasted, because there will be 2 characters now instead of 1. And even ahead, the character which we had earlier, like character long character type of initialization which we had, in that as well, there was 7 bytes wasted for another character. So there were total 14 bytes wasted. Now here you are saving the 8 bytes which was taken by the character earlier, and now the other 6 bytes which are inevitable to be, which will be wasted. It is inevitable for the amount of variables which you are having right now. That is one thing. It is most likely the standard in how you do that. Another thing will be just make right choices for variables, such that whenever you are having like an integer or like a long, whatever you are having, sometimes it is like you don't really, how do I say it, how do I say it, let me think once. So there is one thing, right? If you are having a long in your if you are having a long in your struct, then each and every segment of that struct will be corresponding to the long, right? So if you are having something which comes before long for just one, it takes even just 1 byte, it will be padded such that that will conquer one whole segment of 8 bytes, right? That is how it works for padding, right? So if it was not a long, if it was an int, so it would, instead of taking 8 bytes as earlier when we used long, it will now take 4 bytes instead, which will save a lot of memory, right? So that is a pretty nice thing. So in a way, if you could accommodate something like there will be we technically need 8 bytes, right? We need 8 bytes for a long, so we could take 2 integer, and if it is up to us to optimize it as well. But like if memory is really your thing, you could take 2 integers and do some, whenever you are trying to access it, do some processing with it to get some nice value. You could make a preprocessor or something like that, to preprocessor or inline something like that, to generate a long out of it, it would multiply it and generate a long out of it. It would save space as well, even though you might need to make some extra variables. But again, it would even be you can like, I mean, that is a wholly different thing. If you are talking solely about the struct, it does save some space, so that is pretty nice, I think. So those will be the 2 ways I can minimize padding in a struct. What is the difference between Pragma Pack? Again, this is not something which I know. I have no idea what a Pragma is and all what these are. So I will actually search for the solution for this, because I don't have any idea how this works. What is #Pragma? What does this mean? What is attribute explain all these so that I can answer any questions on these topics. My leg froze. Like it hurts, but like leave it. But what happened? What happened? Why is it? I think it works, right? Why is it showing a network error? Can I open it? Yes, I can open. What is the issue? I don't really understand. I'm logged in as well. So why is this showing it like that? If I retry, okay, it is working now. Let's see. Maybe a little bit of an issue earlier, but let's see what is happening. A great question. Let's break it out systematically. What is pragma in C? Pragma is a compiler directive, preprocessor command, of course, that provides additional instruction to the compiler. Okay, it is implementation dependent, meaning different compilers may support different pragma options. Common use cases: disabling, enabling, warning, controlling struct padding. Okay, I did not know. Again, I think I've heard of this. To disable struct padding, we need something like this. Again, it is nice to know, but again, this is nice. Optimizing code, pragma optimize. Again, I think this one I heard somewhere, that not about optimization, it was something like it can prevent some optimization in certain cases if you would want it. So that is nice. That is something which you can have. So these three things are nice. Again, I did not know about it, but let's see what is attribute in C. Attribute is a GCC Clang specific extension, not standard C, that provides additional metadata to compiler. Used for struct padding, packed, function optimization, memory placement. Okay, so pragma is supported by everywhere, I think. Affects all struct after pragma until reset by pragma pack. Applied only to struct, it decorates. I see. Again, pragma can pack something in between. Not pack, I mean, there is like opening a pragma and then closing of a pragma, right? So there is a scope for pragma. Exactly, I did not focus on this word, but there is a scope for pragma, and even every like many preprocessor directives as well. So like if def, so on. Flexibility, less granular, applies to multiple structs. Okay, more granular, pre-struct control. I see. Again, I don't understand what is the use case and like how you can help yourself with this, but I think this is again not something which I need to know exactly how it works, but yeah, sure. Reset mechanism. Yeah, again, this preprocessor directive can be closed. Automatically applies only to the marked struct. Okay, sure. Multiple struct fine grained control. Yeah, sure. Why about struct padding? Often require exact memory layout when reading hardware registers or network packets. Yeah, this is true. Padding wastes memory. Yeah, padding does waste memory. Performance trade-off. Packed structs may cause lower access to some architectures due to misalignment. Okay. Yeah, sure. Some CPUs support unaligned access but with speed penalty. I see. Common interviews. No. Pragma pack. Why? When would you not use pack struct? Performance is critical. Okay, got it. I think I know. I want to know more about preprocessor directives, right? How do these work? How do preprocessor directives work? What are the basic ones I need to know? And what do I need to know about them? Yeah, this is a nice question. I think it should answer everything which I want. preprocessor directives. The C preprocessor is a text processing tool that runs before the actual compilation. It handles directives, lines starting with hash to modify source code before it is compiled. I see. I see. Again, that's why it. Again, I think this explains why. Pardon. Again, I think this explains why there are like preprocessor directives are used to handle those um, platform specific things, like something which you want only for Windows, you pack it under if def, something like that. In a in a scope of if def, for different platform you have different codes, right? So that's how it arranges and makes stuff out. That's how I think it works. So I think that again, this is now this is clear to me. But for macro expansion, it replaces macros with their definition, and I know this expands header file. It, if you include this, it would get that header file and just put it before, like it would just put it exactly where it is being read, and then whatever the code is below, it attaches, it joins both these things, right? Whatever is written below the include file, it just attaches it with the include header file itself. So that is nice. Macro expansion replaces macros with their definitions. Okay. Yeah, I think I need to study more about define, because I'm not really confident with each and every way define is being used, right? So I will look into this more. Conditional compilation, if def, yeah, include yeah, if it is just if else but for compiler, right? Compiler directives, pragma, special compiler instructions. Okay, I think pragma is specifically for the compiler itself. So I think I know. I think I understand it. Hashtag include file inclusion, inserts contents. Yeah, sure. Used to define constant functions like macros, and conditional compilation flags. Yeah, sure. I think this is self-explanatory, I think. So yes, pitfalls, macros are text replacement, not type safe. Yeah, this is true. It just exactly puts the text inside it. So there is nothing to help yourself with it. So yeah, this is a nice example. So like when you want to use it, you want to surround this with parenthesis so that it works nicely. Fix, always use parenthesis. Yeah, again, I think I said it, I did not read it when saying, but I think this is what I was talking about. This is something which you need to do. Undef, removing a macro, undefine a previously defined macro. Again, I did not know about this, I just saw this. So yeah, this is nice. So like there are certain times when you are like I personally use pragma once. I think it will be there in my project as. So like if I go into any of my header files, I typically use pragma once, right? So this is what it is saying, is that it is telling the compiler to include this only once. You don't have to repeatedly include this, not include, I mean repeatedly include this into whatever you will be compiling this program into again and again, so that it is just senseless for that. You are just defining it again and again. It will just lead to an error at some point. So yeah, pragma once, but I think there is a way to do something other than a pragma once, right? I think I will ask it alternatives. So yeah, again, what I was talking about, whatever the alternative is, I actually know what the alternative is. The alternative will be to define something, a variable for this header file, and if that header file is there, like if it is only, if this header file is included by a certain file, like a certain other file, and if that is again included by somewhere else, so as long as their definition which will be defined for this ppu.h, for this I can like define something like um, pp underscore h, and like when compiler will see this is defined again, it will just not include it at all. So if not defined, I will just have this, and if it is defined, I will just skip through it, right? So yes, I think that is enough for it. So maybe there must be a use case where this needs to be turned off, right? So yeah, this is fine. Conditional compilation, if def, if not def, else if, else elif, and if. Yeah, sure. This is nice. Pragma compiler specific, I got it now. Force struct padding, sorry, struct packing, no padding at all. Yeah, pragma warning, disable a specific compiler warning. Again, this is nice. I did not know about this. Maybe this is actually pretty helpful. I will see. Error forces a compilation error. Okay, yeah, sure. Compilation error, right? Again, this is helpful. Yeah, this is actually pretty helpful. I did not think about it. Yeah, sure. Forces a compilation error and line. Modify line numbers for debugging. So yeah, so all this is only for pre-processing before compiler, so that compiler know what section of the code to include, what section of the code not to include, right? Pragma wants alternatives using if, def, and so on. There is an alternative for Pragma once, I am sure. Pragma once non-standard but widely supported. Yeah. If not defined, define, and if this header is not defined, you will just not proceed any further, right? You will define the header, and then you will end this thing, so this will stay in your memory. So this is nice. I understand what it is saying. Final for embedded system, this is safer. Yeah, again, that is pretty nice. That is nice to know. I think I am done with this question. I understand exactly what is happening. Again, pack was again, both of these pack, but like this is specific to certain compilers, right? You cannot the way each compiler implements this is same. The way each compilers, no, not the same. The way each compiler interprets the same way, but the implements it is different, but it is same for attributes, let's say. So that is clear to me for now. Again, isn't it what I'm talking about? Compiler wide packing, per struct packing. Yeah, packing. Yeah, I did not cover this. I did not say this, but yeah, this is something I needed to say. Now I know. My bad. How does memory alignment affect performance in embedded system? Yeah, the thing is like, let's say you are trying to access a memory inside a struct, and this memory can be like 4 bytes, right? And if there is no alignment, you are just utilizing the memory. I should not explain it like that. The way I think is, let's say you are laying out your struct, and you have some characters filling in till a certain point, like you have 6 bytes filled out in a memory section, which a word which you can access, right? I think word is a pretty nice word to use. So let's say you are having a word which is technically 4 bytes or like 8 bytes, and if you have already filled out certain bytes of that word with memory which you will actually use, the values which you will actually use, so whatever the rest of the memory which is left out, if you would try to put something which if you try to put, let's say, a long inside whatever, let's say 3 bytes are left inside that specific words which are not assigned to literally anything, So when you would put a long inside it, the way it will be that 3 bytes will go here, yeah, sure, but the rest of the 5 bytes which are being not being saved here will go into another word, right? It will go inside the another word. So what the way you suffer from this is that now that it is present in another word, when you are trying to fetch this specific value, you would need to get first the one first word which would contain the first 3 bytes, and then you would need to look for the second word which would contain rest of the 5 bytes, right? And then you would mix both of these together, and now you will have the value. So what the issue which you are having here is that technically fetching you are technically fetching the data twice. So this is not nice, right? So I think that is how it affects the performance, memory alignment. But when you have packing it when you have padding, proper padding, it is pretty nice to have. Given the struct example, yeah, sure, character A, integer B, character C, what is its size on a 32-bit system? Explain why. So integer is 4 bytes, right? Integer is 4 bytes and character is 1 byte. But since let's first look at whatever. Again, I think I should explain it in a pretty modular way. I will start again. First I should look for whatever is the longest value inside this struct, because we would try to extract the longest value, right? We would make the padding vary according to the longest value which we will be having. So integer B is the longest value which we are having. By longest I mean the size itself. So this is 4 bytes and rest of these are 1 byte each. So at once we are having 4 bytes and we are trying to access this, which is just 1 byte, but then there will be a padding. So when we are having a padding, it will take 4 bytes itself, 4 bytes here, and then 4 bytes here. So in total it will be like 4 4 4 12 bytes, right? So that is the size. But I am curious on how it works for 64 bits and 16 bits systems, because the way I understood earlier, not right now, was that when I have a 64-bit system, the way I used to interpret it earlier was that if you have an 62-bit system, it will just put all this together in a single word itself, because it can accommodate that 64 bits is like 8 bytes, this is 4 bytes, this is 1 byte, this is 1 byte, so total 6 bytes. So it can accommodate 64 system and 16 bit system. So again, I used to have that doubt, but then I came to know that that's not how it works. It looks for the highest, the value which has the largest size, which will take the largest size inside the struct, and that's how it is arranged. But let's see what it has to say, right? Integer is 4 bytes on 62, yeah, 32 bits, yeah, sure. Integer is 2 bytes on 16 bit. I did not know that, but yeah, now I know. Character A 1 byte on a 32 bit, character A 1 byte, so it will have 3 padding. Yeah, I was correct about this, there is no mistake for here. But when we are having 64 bit, then also it is the same. Again, I did not know about how this was. Int is usually still 4 bytes even on 64-bit system. Yeah, I think the struct padding which I learned from Nizo Academy, it was actually Nizo Academy, was not exactly correct. I don't really know, but for whatever I am seeing right here, it was incorrect. I think, correct me if I'm wrong, but yeah, the I think that Niso Academy thing was incorrect in itself. Why not 16 bytes? Yeah, sure. On a 16-bit system, typically alignment 2 bytes. Yeah, character A will be 1 byte and integer will be 2 bytes, and character C will be 1 byte. Yeah, sure. So it will be 6 bytes. Yeah, sure. So I think this is nice. What about 8-bit system? Again, 8 is pretty old, right? Nobody uses 8 bits in actual day and age, but 8-bit. What about the 8-bit systems? Yeah, why will there even be a padding for 8-bit systems? Yeah, again, it was stupid of me to even ask about it. So I think I can ignore this much for now. I think I should proceed with it, whatever the other questions are. I think I know pretty much all about what I needed to know from here. No, I think I want to know about more about how other things are, like long, int, character. Again, character will stay the same, but double, DOU, double, float, sizes for 16, 32, 64-bit computers. Again, I think I should know this, right? It is something basic for me to know. Computer architecture. Always 1 byte, yeah, for C standard. Really short will be the same. Integer. Again, this is something which I did not know, but now I know. Long is 4 bytes for 16-bit system. 4 bytes even for 64-bit system. Again, this is kind of weird for me. Like, why is this actually true? Like, why is this 4 bytes? Isn't this same as the integer now? Why is it 4 bytes? Long 8 bytes. Again, this will be 8 again, but like, if you are having 8 bytes on Linux and Mac system, why are you having 8 bytes for long as well? Does not make any sense to me, honestly. Float is 4 bytes. Yeah, it is equivalent to integer as well. Pointer 2 bytes. Again, this is actually what matches the CPU word size. Yeah, okay, sure. The 16-bit is like 8 plus 8, 8 plus 8 plus 8 plus 8, and 8 into 8, right? So 8 bytes. Yeah, sure. Again, weird. This is very weird. Yeah. C long size. Long is typically 4 bytes. On 64 it is 8 bytes. Although it can be 4 bytes on some systems like Windows. Really, I did not know. And if I do int, it will be 2. For 32 it will be 4. Yeah, so int and long range for 32-bit systems is the same, right? I think I know my answer now. So got it. I don't need a whole explanation for this. I got my answer. I'm happy with it, right? How can you enforce a struct to be packed, no padding in GCC. Again, we looked into it, like in GCC we can tell the compiler to use a pragma packing, like there is something for pack, yeah, pragma pack 1. We will enable the flag to pack the struct which comes inside this preprocessor directive, right? That's what you called C, is that what you call C preprocessor directives, right? Preprocessor directives, yes, sure, this is what you call. So inside we will flag this preprocessor directive on before compiling it, and then we will flag this preprocessor directive or such that it removes all the struct padding inside GCC. Yeah. What is purpose of offset of macro in C? Again, this is I don't think it will really ask me to do this, right? I don't really think so. Offset of macro. So what I think this does is, let's say I'm trying to know what is offset of this value inside a struct, right? I think that is what I would want to know, what it says. So let's say I want to know offset of A inside this struct, so it will just tell me what is how to access this value A. Similarly, so I think this will give 1 byte, this will give, no, it will give 0 byte, I think. Again, whatever the value it gives, I don't really know. The first time I'm hearing about it, but I think I can imagine what it says. It will say 1. Let's say if this is saying 0, then this will say 4, and this will say 8, right? I think. And if it was here, it would say 0. This would say if it was here before character and integer, it would say 1, and this will say 4, right? So I think that is that. I will ask this again. I don't think I need this, but I will ask this. I will proceed for the other questions as well. Difference between big endian and little endian. Actually, when I had this printed out before I started the stream, right? So I actually knew about it. I just forgot. I was like, I knew about it. How did I even forget about it? So I actually searched about it on the internet, and yeah, it is. I knew about it. I just could not remember it, and it was that in big endian the most significant bit is stored first in the memory. It is usually the first byte inside the word, first byte or bit, whatever you call, inside the word, right? Word itself. But in little endian system, it is like the word which you are having, the first bit itself of the word will be the least significant bit. That is the difference between these two systems, big endian, little endian. Again, kind of a weird name, but how does this affect struct padding? Again, this is something which I don't know. This is what I do not know, and I will actually ask it over here. How would you manually pad a struct to match a specific memory layout? Yeah, again, I think this is to match a specific memory layout. The way I would think is that if memory layout is really the thing, then I think specific memory layout. So I exactly understand what this question is asking me. It is asking me like I want, so let's take of it as offset. So I want offset of A. I'm given a memory layout, right? Offset of A should be 0, C should be, let's say, 2, 0, 2, and B should be 4, right? If I need to do something like that, I need to put some gap in between, right? So how can I put that gap? I think a way is to actually write something inside here, a garbage value, but I don't think that is the most elegant way to handle it. Again, stop this. I want to change the question. I did not really mean to press enter, but let me look at the answer first, then I will proceed further. Yeah, impact on struct padding. This is what I want to know. Does not affect struct padding. Then why do I? Why did I need to? Why did you even ask me this? Affects how data is read. Again, of course, it will affect the way data is read into the memory. Why did I again? But now that I know, I think it is fine. And now I have the confidence at least to say it. But yeah, sure. Let's. So the way it affects is that this is how you will get the value for. This is how you will get the value when you are trying to fetch it, right? When, let's say, you are trying to get a pointer. So I understand that. I understand what is being said. How to detect endian. Returns 1 if endian. Again, what is this? The pointer to number is typed into. Again, where to even start for this? This is weird. Let's I will say that. But the pointer to number is typed into pointer of unsigned integer of 8 by 8. Again, depends on the type of system, but yeah, pointer for that, and we are taking pointer of that, right? So I see. I did not really read this, but now I. So I'm dereferencing it. No. First I'm referencing it, then I'm dereferencing it, and then I'm. No, wait. Yeah, first I'm referencing it, then I'm typing it such that I'm taking the pointer itself, I think, and I'm directly dereferencing it such that we are talking about the value itself. We are not talking about the variable itself at this point, right? So I understand it now. Yeah, sure. Oh, my back hurts for some reason. When you need precise control over structs memory layout, example for hardware registers, network protocol, or binary file formats, you can manually insert padding to match a specific byte alignment or offset. Here is how. Explicit padding. So, is this what I need to use? I was pretty accurate there, I think. Right? Yeah, I was pretty accurate with it. Yeah, I don't need, and it's fine. I don't need more. In wait, offset of should print off sensor value data. Again, struct sensor data. Where is it getting sensor data from? From here, the value offset of 4 should return 1 2 0 1 2 3 4. Yeah, this is again. I was actually correct that it starts from 0, so that's nice to know. Um, yeah, sure. I know the answer now. Happy to know that I was correct. Why is it unsafe to directly read write a padded struct from two hardware registers? I don't know. I don't know the answer for this actually. I will put it over here again. I will ask it all at once later on, but not right now. How far into the video I am at? 50 minutes. I was a little bit slow, but I learned more. I will say that. Yeah, I think I should note it down. I think I should note it down because I will forget it after a while, right? So I will note it somewhere over here. inside my notebook. um, Over here, right? C programming, uh, revision, and in that what did I learn? uh, Pre-processor directives. I learned about hashtag pragma, hashtag pragma, pack 1 and pack 0, right? These two things I didn't know, and I got to know right here. Yeah, I know about this. Stuff to be packed here. Offset of, yeah, I know this. Indian, little Indian system. Yeah, I know how to manually struct a pad. Yeah, by inserting an array in between it, right? So okay, I'm fine with this. The things which I got to know right here, I'm fine with it, right? What is difference between static and extern in C? Again, static and extern are used for global variables, right? So I think we are only talking specifically about the global variables. So I think it will be fine to explain it. I don't think there is any other variety which comes for extern, because there comes varieties for static keyword, right? So what static does is that it tells the linker that whatever variable is assigned static, like whatever variable is declared static, it can only be read, write, access whatever you want to do inside the specific module, right? The module which you are reading, or like you should say the specific file itself. So that is how it works. But what extern says is that not only do I want this variable to be accessed somewhere else in the file. Again, I don't think that is the right way to, that is a nice way to explain it, elegant way to explain it. I think I should come up with something else. So what I want to say is that when you are having a variable which is declared global, and let's say you want to access it in some other file, right? So for doing that, I think is that you will need to do some you will probably need to do some what do you say, forward declaration or something like that, which is I don't think pretty nice. But what externs allows you to do is that go step ahead of like forward declaration. You don't really have to do the forward declaration yet. You can access the extern keyword and whatever the value thing is, the variable which is declared with the extern keyword, right? So that is how I think it works. Extern, sorry, I did not mean to paste it, I wanted to copy it. Yeah, keyword explanation. So yeah, that is what I think. Even if I'm not, I will get the answers over here, so it will be nice to know. Apart from that, what is the difference between const int? Yeah, what this, right? So first of all, I will look at the left. Again, I should notice because I forgot about this the last time. Const, look left and then right. Whereas for pointers, look right and then left, right? So yeah, so first of all I will look at the left. There is nothing to the left, so then I will look right, and what is here is integer. So what I think it is that constant integer p is a pointer to constant integer. This is how I understand it. Constant we are having over here, and over to the left we are having a pointer itself. So this is constant pointer P is a constant pointer to an integer, right? So integer can be placed, how do I say it? Again, I think for explaining this I need to explain this first. Whatever constant integer pointer, right? So what this is saying is that whatever this pointer will point to will be a constant integer. You can only read it, you cannot actually write it, and if you do so you will get an error or something like that. But when you are having something this way, what will happen is that const this says that you are having a constant pointer to an integer's value will change for sure, but you cannot really change the value of address to access that integer or any other integer. Like you cannot play around with pointers and expect it to work just because it points to an integer, right? So that is what it is saying. And here it is again, this is self-explanatory. Again, I think I should practice speaking self-explanatory because I'm not really nice at pronouncing it. Yeah, this is self-explanatory, that this is constant is used twice, so it is constant pointer to a constant integer. Neither you can change the address of the pointer, nor you can change the value of the pointer. So yeah, why should you avoid using malloc in embedded? Again, I think I should confirm this. Constant pointer to constant integer. Yeah, at least that's nice to know that my concept is correct, right? Why should you avoid using malloc in embedded system? What are the alternatives? The issue with malloc is that again, dynamic memory allocation. The issue is that, let's say you are having, again, in short terms you can have memory leaks. That's the whole point. And you are having limited amount of resources in embedded system. That's all this is about, right? That's why you don't use dynamic memory allocation inside embedded system, because it is not really a safe thing to do. But that why it is, what makes this unsafe is what I think this question is trying to ask me, or at least that is something which I expect as the follow-up question to my answer if this was being asked to me inside an interview. So in that case, why should you avoid using malloc in embedded system? My answer would be like, you're calling a function and it does some memory allocation itself, right? It does something like that, and then you call another function and so on. So you do stuffs like this, so it becomes nested after some time, and it's not always necessary that you are successfully able to free the memory, right? So in some cases you are maybe returning a little bit early, you are having some conditional statements. So whenever you are trying to return from there, whenever you are trying to return from a function, you should free up the memory whatever you have allocated, right? So you have to carry around those pointers to free up this memory as well. So that is the thing, that you have to write it everywhere, and it is not possible to do it each and every time, right? Not that it is possible, I should not say it, but like the thing is that it becomes hard to maintain all this thing inside your mind. So it is easy to forget that you need to free up the memory, and it does crazy stuff, and it causes memory leak. It continues to use the memory resources which you have allocated inside that embedded system, and it gets exhausted pretty easily. So that is not really safe. That is why you don't use malloc inside embedded systems. What are the alternatives? I don't know the answer. I can make up some answer, but I think I or myself want to know the answer. So consider me curious. So yeah, I think that is that. What is a function pointer? How long have I been going? It is 1 hour exactly. So yeah, what is a function pointer? Like, am I streaming correct nicely. Let me check first. Yeah, view my channel. Sure. Oh, someone is actually commenting here. Thanks, Yash. I appreciate it. Hi, I use ChatGPT. Your voice is not clear and background noise glitch your voice. Um, what can I do about it? I think I think I will do something about it the next time. But for now, I don't really know any solution for this. Again, I'm using a headphone, right? But I don't think I should blame it on the tool itself. Again, headphone is doing its thing. So um, I don't know. My voice is right. My voice should be pretty clear. Very voice should be pretty clear. Apart, if I don't have any background disturbance, I think the thing is that I'm having background disturbance and it is interfering, right? So I will look into it. Whatever is the issue, use ChatGPT. No, I think whenever I'm trying to learn something, ChatGPT is not the best way to get answers, right? It does not really help for me. I sometimes get wrong answer. It tries to agree more with me instead of telling what will be the nicest thing to have, which I don't really like. If it does not know much information, I would rather have it say that it does not know, or just give some basic information so that I can come up with the answer myself. But that's not how ChatGPT works for me. That's why I don't use it. So yeah, that would be my answer for you. But yeah, thanks for saying some things, because this is the first time someone actually commented for me. That's pretty nice. Thank you for that. So I think I will be continuing with what I was currently doing. So yeah, what is a function pointer? Again, function pointer is literally pointer to a function, which um, pointer to a function of a certain type. Again, what function of a certain type exactly means is that function which takes specific parameters and returns a specific value. No, specific type of value, like specific data type, right? That's what a function pointer is. I'll give an example of its use. Again, I don't think there is much to say about it. Like, i think I think it did not really think that well before asking me questions like this. Again, the example for this would be like, let's say I'm making a CPU itself, because I have done this. I will just tell what I did. So let's say I'm having a CPU itself, and what I'm trying to do is uh, have something defined, whatever the function implementation would be like. Let's say I'm having a CPU. It will have addressing modes, it will have instructions. CPU can perform various different things, right? So for each cycle, I want to define which instruction I want to perform. So it's not like I will have a switch case type of thing for every specific input, right? It is not something which I would want. The way I think it would be elegant is for me is to have a lookup table and just directly point to a specific function pointer, right? So as long as I have a function pointer, I can just exactly point to that function itself, right? So that is how I think of it. I think that is not the best way to explain it, but I think I can come up with a better way to explain it, right? I will try a bit more. A function pointer, exactly, right? So what would it be? Again, how would I use it? So what I would think about it is that, um, again, it is easy to explain with object oriented programming, right? It is pretty easy to explain it, but in this context it becomes a little bit harder. So its use in embedded firmware is that, you want to do something with a specific type of function, but there are various type of implementation for that function, right? And that is how I think I should explain it actually. So you want to do something, and there are various ways to implement it, and all this implementation do different things, but all you want are all you want is do one of those things, one of those different things. So what you would do is that you would take um, you would take any one of those functions and point their pointer to this, so that whenever you are calling it, you can using the function pointer, you would actually call whatever it is being pointed to, and later on when you don't need it and you need something else, you can replace out the pointer, you can change the thing it points to with some other function. And it is pretty nice when you want to like pass it as a parameter, like hey, like you use lambda functions inside other programming languages, right? It is pretty neat. So if you want something which is like a lambda function inside C, I think that is how you would do. You will pass around a function pointer and then do stuff like that. So that is how I think function pointers work. That is how I think it should be. But yeah, that should answer my question, right? Yeah, it is actually pretty nice explanation for lambda function as well, because let's say you want to pass a function as a parameter, so that is how I think you would do it. um, yeah, I think that is pretty nice of an explanation for me. So yeah, what is the difference between define and const for the constants? I don't know. I know const is read only thing, but I think define is there for um again, how do I say? No, again, I think there is a better explanation for this. The thing with const is that the program has the read only access to that memory location. Memory lo- the program itself has the read only access to the variable which is defined as const. But any other thing, let's say operating system processes or key, let's say input or interrupts, stuff like that, can change value of that point and the value of that variable itself. So the program itself will not change the value, but the other things, other stuff like input from keyboard devices, stuff like that, operating system, things like that, that can change the value. But when we use define, only the compiler has access to um, the thing which is defined with this preprocessor directive, right? So whenever you replace it, it will actually take the value and just put it inside the wherever we have defined the thing, whenever you are using that defined preprocessor directive, right? So that is the difference. It will actually put the value inside, and it happens before compilation. That is a wholly another thing, and I should not go into that, but yeah, that is something which I think I should say. So yeah, maybe if you do volatile const, it will resemble, no, not volatile const, no, again, you cannot prevent anything from happening for that, right? I think this is something which should be used for const things, right? Again, I never thought about it before, that um yeah, define is actually better way to use something than const, just because like other programming languages used const does not mean const is the best way to implement const in C. Yeah, so right, that is the thing. It is pretty nice now. How does restrict keyword optimize your pointer operation? Again, I don't really know what restrict is. This is the first time I'm hearing about this. I don't think that anyone is going to ask me. I've never seen this, so I will just skip through it. What is a bit fill in C? When would you use it in embedded programming? I don't know this. What? a bit field is, I want to know. I will just have it as a question itself. So yeah, apart from that, explain difference between mem copy and mem move. Yeah. So um, I think you are going to pass two pointers over here, and you will copy value from one to other, and from mem move you will move the value from. I think you are going to interchange values. I don't know. Again, all these are my guesses, so I don't really have any answer for this. I will just put it as is because I want to know the answer for that. What is undefined behavior in C? I don't. I think I think I know exactly. Like whenever you are trying to um, uh, क्या तो बोलते हैं, क्या बोलें, what am I trying to say? Undefined variable would be like whenever you're trying to access uh, value of a null pointer, that leads to an undefined variable. But again, it has always been a little bit confusing for me to imagine. That's why I'm a little bit hesitant to answer this. Not hesitant, but I don't really have a very well defined answer for this, but I want to know the answer for this. That's why I will put it as one of the questions as well, because I need an answer for that. So yeah, again, I think I should ask all these for once, and then I will move on to the next steps. I actually want to drink water, but I don't have any. So again, I think, wait, what should I do? I will minimize this. I will just increase the size and let people know that I'm going to drink water. I will be back. Hello, hello. I am back, so I think I can continue. Where was I? Again, I was taking answers for this, right? All those questions which I had stored earlier. Why is it say unsafe to directly read and write a padded struct from or to hardware registers? Padding is compiler dependent. Different compilers may insert different padding, break the expected memory layout. Yeah, this is true. Hardware registers often require strict alignment. Example, 4 byte aligned addresses. A padded struct might misalign fields. Yeah, sure, that is true. Um, Structs don't handle byte order automatically, leading to incorrect. Yeah, that is true. Yeah, I see that. Leading to incorrect read writes on big little endian systems. Yeah, uninitialized padding bytes may contain garbage corrupting hardware states. Yeah, that is true. May contain garbage corrupting hardware state. Yeah, yeah. Actually, I did not ever think about this, but like you're only accessing reading writing into those memory uh, into those variables which you can access through the struct, right? The memory which you cannot really access from the struct must be containing garbage values. So when you are trying to access it, you might do some incorrect things. So I never thought about it. Now that I think about it, it is pretty actually some pretty sick. So yeah, yeah. This is something which I was thinking. Like maybe if you use Pragma Pack, you can do something about it, right. So yeah, I actually never thought about it. How do I use registers in C? Using registers in C, understanding the register keyword in C, right? Register int I. Okay, so you are trying to access access the address of that register, which is obviously going to lead to an error, right? Again, I understand it. I understand what it means. So yeah. So apart from that, what I was thinking about was extern keyword, right? Extern keyword explanation declares a variable function without defining it, tells compiler this exists somewhere else, right? How do I use it? Int counter equal to 0, extern int counter, linker revokes it. It is not exactly the way I thought about it. What I thought was like, if I do extern int counter, whatever value it takes inside this specific module, when I'm trying to access this specific thing from outside this file, it will not give me an error. But it is not like that. Now that I see, again, it was a little bit stupid of me to think that, now that I think. But yeah, at least I know now. And yeah, this seems pretty neat, that if I'm using something some way inside my file, and when I'm trying to use an extern, it just tells the compiler that hey, this exists somewhere, just use it. Again, as it says over here, right, this exists elsewhere. So yeah, this is pretty neat. So I think you must also be using this with careful. You must use this carefully as well, because hey, maybe I put some wrong spelling over here, and maybe the whatever the wrong spelling I will put here, maybe it exists somewhere inside any other file, so it will cause me issues as well, right? So that is not really it is not really a nice thing to have, because I will be accessing these values as well, right, if I have that. So yeah, that will be an issue. That's why I think you should use this with care as well. I think I should note all this down, because I have asked this, right? Unsafe to put structs inside registers directly because of structure padding. Apart from structure padding, what was it? Little, yeah, big endian confusion. Apart from this, it could be garbage values in paddings. Yeah, I think these three are the reasons. Unutilized padding, yeah, and alignment issues. Yeah, I think that is self-explanatory, right? I should add that. Yeah, I should add that actually. So yeah, I think that is pretty clear. Extern keyword, yeah. I think I should write extern keyword as well. Um, extern int hello. Finds hello defined somewhere externally. I should not say external, globally, and uses its value. And not just defined, initialized. I should just use initialized over here. Linker, extern tells the linker to find hello initialize somewhere globally and use it as the value, right? So yeah, that is a pretty nice explanation. Using functions from other modules. Yeah, this is nice, but I think this exists. Yeah, I think this happens even if you just simply forward declare. Does simple forward declaration does this too? Behavior compare function, yeah. Yeah, I understand you can use it for clarity, but yeah, I think practically to say it is not really what I want. So yeah, I think I should make changes in my own code as well, right? Where I had cpu.c, no, cpu.h. I can do extern struct on declaration of a type. I see. Wait, do I see? Wait. I don't want to mess this up. On a declaration of a type. Again, this is a type, right? I'm. This is just a type. I got it. I was messing this up. If I had type def struct bus and if I had type def struct bus and again another bus, then it would make sense. It would have made sense for me to know why was I writing it. But yeah, I should not use it. If I should only use it for variables, I should not use it for type declaration. Yeah, I should be clear about it. I messed it up. Yeah, my bad. my bad about it, but yeah, I think I can continue on to the next question. This is clear to me right now, so I think this is fine. Embedded system example, hardware register. Again, why, what is this part? I was actually looking into this, not the next section. Alternative to heap fragmentation can cause runtime I don't know. Again, I know what heap malloc does. The heap allocation causes in long running systems. I don't know what heap fragmentation is. I don't think I need to know as of right now. But yeah, non-deterministic timing unsafe for real-time system. Again, I don't have any idea why. But alternatives to this would be, yeah, just use a simple buffer. I think that is enough. The people have come up with things like arena and stuff like that, but it still is dynamic memory allocation. Again, it is much more safer, but yeah, it technically is, it does still has these two problems regardless, right? So yeah, heap fragmentation, again, I did not really think about it back that time, but now that I think about it, yeah, if these things like this are also an issue. You cannot just expect a memory which is just shared to be present over there safely for a very very long time, right? Static allocation, fixed size, no runtime overhead. Yeah, this is the best way for now. um, Pre-allocate fixed block sizes, pool allocator. Yeah, all these are like the same thing, right? Void foo uint 8 stack buffer, auto freed on function exit. Yeah, you can have it globally or you can have it on the stack. Yeah, for sure. Bit fills in C. Yeah, this is something which again, acha, this I got it. These are bit fills. I know this. I exactly know what this is. So what is being said here is that we are taking the first bit out of the uint 8 value, which we'll be putting in, which will be assigning it over here, right? Like let's say you are assigning 12 inside enable, so it will just take the first. Let's not take 12, it is not a nice number. Let's take 15 for example. 1 the last three things will be 1 1 1, and for that 1 1 1, when we will have the value of enable as 1 1 1, when we will read it again, it will be just 1 because it is taking just the 1 bit out of it, right? Another thing is uint mode 3. The thing with this will be like, let's say I have 31 1 1 1 1, and then we will assign 31 to we will initialize or like assign 31 to mode variable. So when we will read it again, it will not be 1 1 1 1, it will be 1 1 1. So technically 15, right? So 31 becomes 15. That's what's going on over here. Unnamed padding. Again, you can do this. I did not really know about this, but yeah. I actually want to know more about bit fields. More about bit fields. Bit fields, like again, what was the use case? Packs flag in a single byte efficiently encode data. Compiler depend, again, that's fine. Slower than bit masking in some cases. Yeah, efficient because you are technically taking out the values separately and then probably type casting it. Again, I don't know how it actually happens inside the assembly, but yeah. Where was I? Embedded use case, registers. Exactly, registers is somewhere where I would think this is how it is used, right? Again, I have used this in structs for that. Again, I think I have used it, right? I had a ppu.h, it should be here. Yeah, I have this struct which is just having all these registers saved like this, and then I can either use this I can either use these variables themselves to um, alter the value, or I can use this unit register, which will like overwrite these values, because it is technically a union. But yeah, regardless of that, where was I? Again, I have done some changes over here. What did I change? Again, is this not committed? I thought I had committed. I did not know. Git diff. Yeah, there is code which is not committed. I will commit it later on, or maybe just cross check if I have done it correctly or not. What does this do? I wanted to know this. Let's see this. Um, Overlap handling, undefined if source. Again, I want to know this. Character string hello. Yeah, so like it is um, a thing of size 6, because this is 5 and there is a null terminator, and then there is mem move. We will start from string plus 1. Why string plus 1? Got it. It is going to move it, right? Mem copy string plus 1 string and 5. Got it. So if it overlaps, it is going to give an error or something like that. I don't know, probably do some segmentation issue or something like that. But the thing which I can take from here is that when you are using memo move, it actually just takes the value and just moves it onto some other points. It technically is a copy, but even if it is overlapping, then it will just overwrite it. But in case of mem copy, it will not overwrite it. It will just do undefined behavior, right? I think undefined behavior. And for undefined behavior, okay, I did not mean to do the back thing. Where was I? I was here. Undefined behavior in C. Code that lacks predictable results per C standard. Compiler may do anything. Okay, buffer overflow. Undefined behavior, out of bounds access, crash or worse. Initialized variables, yeah. Why care? We can undefined behavior can silently corrupt memory or behave unpredictably in embedded systems. Yeah. Again, all these are clear to me now. I don't think I need to go much deeper into these specific topics. Apart from whatever is left is, what was it? I have done till here. The things which are left is embedded system and embedded specific C questions and pointer memory management. I don't think they will ask me this, because yeah, so far we have not done anything regarding these, right? I'm just applying for an intern, so hopefully they expect me to know this when I'm applying for placement, but not right now, right? Because I have not done anything for embedded system currently, so I think I should look into this. I want to know more about bit fields, but before that, dangling pointer, how can you avoid it? Again, I knew what dangling pointer was. I just forgot it right now. Because I read about this somewhere. Again, I should be knowing this. It is a pretty common topic. I'm well aware of that, but it's my fault. I should know this, but I don't really know what is a dangling pointer. I will specifically search for this dangling pointer. What is it? Dangling pointer in programming is a pointer that no longer points to a. Yeah, got it. So like we have done a dynamic memory allocation, and you have used a pointer for it, right? Then we have freed up the memory which was being pointed with this pointer. So now that whatever the pointer points to is freed, this pointer becomes a dangling pointer because it no longer points to a valid memory, right? The memory which is, again, is it a valid memory, or how would you call it? Yeah, it no longer points to a valid memory location. So yeah, again, I think that was a nice document or whatever this is. I want to know more about this. So, dangling, void, null, wild pointers. I want to know about this. I will read this. I want to read this. I will keep this saved over here. I will move on to the next question. Explain the difference between int this whatever this is and this whatever this is. So like this is pointer to p of type integer, right? I think that is it. um, so p is a pointer, wait, yeah, p is a pointer of type integer, and over here p is a pointer to array of 10 integers, right? That is exactly what is happening as far as I know. Yeah, again, p is a pointer because it is not directly written, there is a bracket in between, so p is a pointer of array of 10 integers. So yeah, this is pretty clear to me. How do you use realloc safely in embedded environment? I don't know, they won't ask me this, I'm pretty sure. It is a high level concept for me, and yeah, I think I will skip through this because I want to learn this in much more depth later on. Void pointer, again, this is something written in this documentation. I don't know what void pointer was, but I was curious when I saw this void pointer, null pointer, wild pointer. I wanted to know more about this, so I directly opened this document. I will look into it in some time. Ring buffer, again, all these things I don't think I need to know for now, so I will just skip it. Why is printf generally avoided in embedded system? What are the alternatives? Printf probably is avoided because you're writing onto the console, like you don't have specific thing assigned to it. Like if you had fprintf or something like that, you would specifically define like this is something where you want to write it, but when you are doing it for console, maybe the program is taking the console output as some sort of input as well. I don't really know. I don't know how it can happen because it is just having an RTOS. Let's say we are having an RTOS, multiple processors are working, so maybe some processes take input from the standard input and probably the standard output as well, so maybe that could lead to some sort of clash. I don't really know. Again, this is an assumption for me, so I will put it onto here. How do you read write to a memory mapped register in C? No idea. Again, they won't ask me. Again, these are embedded systems question. They won't ask me, so I will not go that much further into it. But yeah, I want to know these two things, and then I think I can wrap up for what I was working on it. Right? This has been like 1 hour 40 minutes, nearly 100 minutes of it. So yes, maybe I still want to continue doing this because I think I'm in a pretty good mood today, surprisingly, and not just that. I think I have I'm motivated today, unlike yesterday where I was like I don't know what to do right now. There are so many things for me to do, but like I was just overwhelmed with whatever I had to do, and I was not actually getting anything done, right? So after I live streamed yesterday, I think I felt pretty nice, and it carries on to today as well. So I think I will continue studying the way I have been. So yes, I will continue. So probably for some half an hour more, I think. So where was I? Bitfill in C, deep dive. Bitfields allow packing multiple variables into a single integer at bit level, saving memory resources. Yeah, this is exactly what it is used for. And specified number of bits a field occupies, unnamed fields. Yeah. Key properties, packing, memory efficiency, hardware register mapping. Again, I did not. Again, got it. This is probably what I was thinking about as well. the way I had it in the NES. Again, I have removed it, but yeah, the way I had it in the NES was working the same way, I think. Compiler dependent behavior. Yeah, these are properties, right? It's not like these are way. These are probably not. This is not probably trying to tell you the ways this is helpful. It is just telling the properties. So embedded use case. I think I've said a little bit too much, and like my throat actually hurts right now. I will I will probably finish this much, and I will read this on my own. I think because I don't have that much. I don't think I should overwork myself into this. So yeah. Uh, Configuring hardware registers. So I understand what is being said over here. Enable baud parity, yes, sure. Volatile, again, this can be varied. And so the way I think hardware registers work is that what hardware does is that it chooses specific values inside the memory, the RAM, and takes it as the way to control it. Like you can either switch it on off, stuff like that, to control the hardware itself, or maybe you can you can use it to have values from the hardware. You can do input output using these registers, right? But they are not actually the actual registers. These registers are memory locations, right? UART, stuff like that, right? Got it. I got it. Network protocols parsing CAN bus messages where signals are packed into 8 byte. Again, I don't think I need to be wearing this while I speak, right? Because again, my ear is all sweaty because I've been having this on my ear since so long. But I don't know how it sounds when I have it like this. I will actually check once I finish with this, but I want to see how it sounds. Is there even any difference or not? So yeah, because it affects my ear as well, because as you should know, wearing headphones for a long time is can lead to stuff like infection and all that stuff, which is not very nice. So yeah, apart from that, network protocols, yeah, sensor pack data packing, all that stuff, yeah, all these are pretty reasonable. Apart from that, pitfall, again, I should not be going this deep into it. Again, I think what I know is enough. Why to avoid printf in embedded system? High memory usage. I did not think of any of all this stuff, right? So I think I should read. Reason to avoid printf: high memory usage. Pulls in large stdio library. Yes, I did not think about this, but yeah, this has a point. I have to also think about the libraries which I will be using, right? I cannot just blindly import all those. So yeah, slow performance formatted input output is computationally heavy, bad for real-time systems here. So the way I'm taking it is it is not very performative to have it happen in real time, right? It costs performance. Apart from that, it also costs memory because you are trying to import all those libraries for printing stuff out, right? Apart from that, no direct hardware support. Again, this is I will not look into this because I don't really understand what is being meant over here. Apart from that, dynamic memory allocation, yeah, I can see this because the library which you will be taking in, you don't know what is implemented inside those libraries, right? You don't really know anything. So it is better to use any printing or logging thing which is made specifically for embedded system, which does not use dynamic memory allocation, is very performant, stuff like that. That will be pretty nice. Alternatives, yeah, all these things, right? As I was thinking, yeah. So yes, I think that is it. um, I think I've covered all what I wanted to cover today. Again, all these things I will be covering on my own. I think I have to still look into these two things, right through, right back, and like cash replacement policies. I know a little bit of, I actually know these. I have to revise these things, LRU, FIFO, random stuff like that. Apart from that, yeah, right policies, I have to look into this right through, right back. I don't know what this is. And cash coherency, I don't know. I will look into it. I will determine whether it is that useful or not for me in interview stuff. But yeah, uh, I think I will finish cache memory today, and all these things I can do by myself, if I want to later on, because yeah, I just wanted to cover cache, being honest, because I thought that was the most important. Uh, this is something which people wanted me to, people who had jobs in embedded systems, right? My seniors wanted me to look into cache specifically. So yeah, I'm looking into it. Probably I will. I feel little bit I feel more confident over here, knowing cache memory. But yeah, I think that is it. I actually also want to look into memory layout of C. I will create another file, 21 July .md, right? I will add, again, the title will be the same, 21 July, and in that I want to look into memory layout of C in depth, not just knowing what it is, not just knowing where data goes. I want to see, um, I actually know decent amount of stuff. I just want to I want to be reassured about what I know about it, right? I think I know decent, I have decent knowledge on these, on memory layout of C. But the issue with it is that, it's still, the issue is that there was a question inside the uh, PDF which I got from Texas Instruments, right, for internship, where they gave sample questions which they will be asking inside the interview, uh, topics which I should be covering if I want to appear for OT or interviews, right? So all those questions I had to look up, and I studied them and got to know. So yeah, those included, specifically memory layout of C, but I did not really look into it in depth. In I actually, the thing is, I know about it, but I did not specifically look for this, because I wanted to study how C program compiles itself. So when you study that, you have to study this section as well, memory layout of C. So yeah, I know a little bit stuff, but I will try to learn more about it. So yeah, this is it. I don't think I have anything else to cover. This is actually the first time I have actually finished all the stuff which I had planned for today. Again, this is from last day. If I remember, I know I had this open for the whole day, but it was not 19 July today, right? It is 20 July, and it will be 21 July in just a minute. So yeah, um, all this is planned for tomorrow, or probably today in some seconds. But yeah, I think I have covered all this, and I'm pretty happy with it. So I will just exit all this stuff out. Again, what are you guys thought on this? Because I think this is pretty cool. I generated this ASCII arc. There is like Daft Punk over here, and this is pretty cool for me. The way it looks, this ASCII arc. I had this uh, CD downloads, and like it, I tried a lot of stuff to generate, but it was just so much fun. So yeah, this is just for fun. There is nothing. Again, I should not have clicked the upward arrow. I want to do what I want to do was to have that. Not this one. This one probably. No, 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 not this one as well. Which specific photo was I looking into? Actually, I will open the files. I did some tweaking with my Linux setup so that it looks pretty nice, and I think it looks amazing. Honestly, it looks amazing. I'm pretty happy with what I got. Yeah, this is the output which I was talking about. This is actually really amazing for me. I'm very happy with what it is here. So yeah, this is what is over here. Exactly the same thing, I think. 4418, yeah. So whatever it is, I'm pretty happy with what turned out. But yeah, I think I will be stopping over here, right? So I also have to do. So I will just quit. Yes, and that process stuff, all those stuff. YouTube, go into YouTube and look how it is going right now, and how, yeah, I did not mess up any part while doing this live. So yeah, I think it is nice point to end all those stuff out. mm, I actually have gained quite a bit of confidence in talking about stuff which I want to actually talk about. And what did I do? What really happened? Did I just wait? Again, where did it go? I think I clicked something and it just disappeared. Wait. Um, no, not scenes, not sources, not audio mixer. Oh no, none of this. View stats. No, not stats. No, not this. This is, yeah. Well, why did? Oh, I think I clicked on this button. That's why it was. I mean, again, leave it at that. But yeah, this is really nice. I'm making a lot of progress. I'm gaining a lot more confidence doing this live, and I think I will continue to gain a lot more confidence as I go further down. Right, my English is becoming better. I'm feeling more comfortable. I'm feeling much more comfortable with my English, even though I'm stuttering a little bit. But at least, in my mind, I'm having that confidence to pick up all those stuff which I'm messing up with my stutter. So that makes up for it. Hopefully, in future, it as my English becomes better, this stuttering decreases. But what the progress is so far, even in all these 4 days, not it has not been that long, to be honest. But yeah, all this 5 to 6 hours, whatever this is, has helped me a lot. So I'm really grateful for that. So yeah, I think I will be ending it over here.